This video looks at weighted mean. So weighted mean is a way of calculating a mean where some things have more weight attached or assigned to them. So let's have a look here at the equation. So we use x bar to represent that mean. And the way that we calculate the weighted mean is that we take the weighting of each element, the w's, and multiply by the element themselves. So we do that for each element. Just a note here that the w is the weighting. So we'll just call that the weight. And we add all the weights times the elements themselves, and then we divide by the sum of the weighting. So a short way to write this equation out is the sum of all of the weights times the individual values divided by the sum of the weights. Let's look at an example here to give you an idea of how this works. So here we have a company. They score applicants on the following scale. They use categories that are scored out of 5, and they look at 5 different criteria. 1, 2, 3, 4, 5 different criteria, and each one of those criteria has a weighting. So the weightings are here. Now somebody needs to decide what those weightings are, and this company has decided that these are the weightings. These are the scores that a certain applicant received. So for example, this applicant received a 4 in education, and the education has a weight of 2. So just using the equation from above here, we know that the mean, I'm going to leave a spot here. I'm going to write that down below because I think that'll be a little bit easier. So the mean is just the sum. So x bar is the sum of all of the weights times the x values, the individual values, divided by the sum of the weightings. So we have our scores, we have our weights. We need a column here. I'll just add in an extra column that is the weights times the x values. So we'll just call this wi times xi. So this is where we're going to multiply these two values. Fairly straightforward to do here. 4 times 2 is 8. 2 times 2 is 4. We get a 15 here, a 15 here, and a 4 down here. Now we need to add all of these up. We need the sum of this column. So I'm just going to leave a little box down here for the sum. So that sums, I believe, to 42. So that's the sum. So that's the numerator of our mean. So we get 42, and sorry, that should be a 2. Let's try that again. So that's a 42. And then the last part here, the denominator, is the sum of all of the weights. Well, here are the weights right here, so we just need to add up all of the weights. So when we add up the weights here, we get a total of 12. And 42 divided by 12 works out to, I believe, 3.5. And so we get that the weighted mean is 3.5. So that's how we can find a weighted mean. You can see here that the table is kind of useful and is helpful. Now, the second part of this question says, what do the weightings indicate about the company's priorities? Well, the fact here that the company has a higher weight, so a weight of 3 on each of these two categories, indicates that they value interpersonal skills and communications. They don't put a lot of weight into references, probably because most people who put a reference on their resume would only include people who will say good things. So that's probably one reason why they don't weight that very heavily, and obviously they think that communication and interpersonal skills are important. So there's one example of how we can use a weighted mean or find a weighted mean. Let's have a look now at a second example. This one's a little bit different, but the process is actually the same. So in this case, we have a table that shows the number of tickets purchased. So here are the number of tickets purchased right here, and how many people bought these tickets. So we could actually, if we wanted to, separate this data out. So it's kind of grouped a little bit based on the number of tickets that people bought. We could separate it out and calculate the mean that way. It's time consuming. and kind of often is not really necessary. So what we can do is we can actually use the equation for a weighted mean to find the weighted mean here. So let's have a look at what that looks like. In order to do this, I'm going to set up the table just like we did the last time. So this will be, let's call this the number of tickets. Let's try that again. So number of tickets will go as one column. And then our next column will be the frequency. And these would be like our weights. So the frequency is kind of like the weighting. So for example, the fact that this first entry in the table, 2 tickets, has a frequency of 10 means that it's really weighted more heavily than, say, this 4 or the 5 or any other number for that matter. So what we're going to do here is we're going to take the number of tickets and multiply by the frequency. So I'm going to put up here just the fact that this is like having a weight, and this is like our x value. So here we're going to, sorry, that's a bad x. We're going to do the x value, sorry, the weightings times the x values. So then we fill in the table. We've got 2 tickets, 3, 4, 5, 6, and 8. The frequencies here, I should have maybe just left some room on the other side so we didn't have to rewrite this table, but you get the idea. 10, 6, 8, 3, 5, and 4. So then we're going to multiply all of these values together. So the tickets times the frequency, that's going to give us 20 here. And if you think about what we're doing here, just so you don't lose sight of what it is that we're doing, if there are 10 people that bought 2 tickets, that's the equivalent of 20 tickets, right? So 10 people bought 2 tickets each, that's the equivalent of 20 tickets. So that's what we're doing here. 6 times 3 gives us 18. We get 32 down here, the 15, a 30, and another 32. And again, we want to find the mean. So the mean here is just the sum of the weights times the x's divided by the sum of the weights. So the numerator is just the sum of this column. And if we add these up, I think we get 147. So that's our numerator, 147. And our denominator in this case is the sum of the weights, or the number of frequencies. So again, this is the total number of tickets sold. So if we add these up, we should get 36. If I've done that correctly. And then we could take our 2 values and divide them, which gets about a value of 4.1. So this indicates that the mean number of tickets is 4.1. So that's an example where it doesn't actually look like this needs to be a weighted mean, but really it's doing the exact same thing as a weighted mean without having to split the data into little bits and pieces. Alright, let's have a look at one more example. So this example is a little bit different. Basically, this example has us looking at a probability distribution of rolling a 6-sided die and calculating the expected value. So just a reminder, the way that we do this, we have our random variable here. It's the roll. What are the possible outcomes when we roll a 6-sided die? And those are just the numbers from 1 to 6. In this column here, we'll list the probabilities. 1/6, 1/6, all the way down because it is a fair die. And then remember that the way that we calculate the expected value is we take all of the x values and multiply by the probabilities, and then we sum up this column. So we'll go ahead and fill in the table, and then we'll sum this up. So 1 times 1/6 is 1/6. 2 times 1/6 is 2/6, and you can get the idea here of what's happening. And then we want to sum all of these up. So when we do that, we get a total of, what does this give us? This gives us 11 plus another 10, I believe. So 21, 11, 15, 18, 21, and that's 21/6. So again, if you wanted to, you could type that into the calculator, and you could see that 21/6 is equal to 3.5. Just a coincidence that's the same as one of our other answers. So you might be wondering, what does the expected value have to do with the weighted mean? And I think if you look at this table and you compare it to the table on the previous example, so if we compare it to the table here or the table on this example, you can see that in both of these cases we had some value that we multiplied by some other value, the weightings in these cases, and then we added that column up. So the process here of finding the expected value was no different. We had these values, these were our weights, so these were our x values, these are our weights, and then we just multiply all of those together, add them all up, and we get an expected value of 3.5. And if you think about that for a moment, now some of you discovered this actually when we were doing expected value, but if you think about it, it kind of makes sense, right? The expected value is the long-term average. What should happen long-term? And so there are different weightings. In this case, all of the weightings were the same because this is a uniform distribution, but you can see that those different weightings would kind of apply. So the expected value is, what did we say, 3.5? So that, in case you're wondering, was the expected value was equal to the sum of the x times the p at x's. And if you compare that to the formula for the weighted mean, you might say, well, in the weighted mean example, we always divided by the sum of the weights. So we should actually be dividing here by the sum of the probabilities. And hopefully you realize that the sum of the probabilities here should always be 1, because remember that the probability distribution lists all possible values for the random variable. So all possible values are listed here, which means that all of the probabilities are listed here, and if all possible probabilities are listed here, then they must sum to 1. So in an expected value kind of question, this is really about finding the weighted mean and just knowing that the sum of all probabilities is going to equal to 1. So that's a nice little connection to what we've done before with expected value and weighted means. So that's an introduction to weighted means. They're not really that difficult. It's just a matter of understanding how to deal with the weights, and basically you just do what we've done here. So hopefully that clears things up a little bit about weighted means and also the connection between weighted means and expected value.